Yes, doctor, shall we start?
Yes.
Is everything fine? Yeah, you can hear me?
Yeah.
Okay, fine. Yeah. A very good afternoon, one and all, to our fourth international webinar series, the international webinar series conducted by Mechanical Engineering Department of Universal Engineering College on the topic Essential Technologies and Career Opportunities in Mechanical Engineering. Today, as our chief guest of the day, we have Dr. Sangeeth Kallatt to give a talk on prospects of building career in micro fabrication. Before we hand over the mic to our chief guest of the day, let me introduce our speaker to you. Mr. Sangeeth Kallatt, he's doctor by the way. He has worked as Senior Process Integration Engineer at Center for Nanoscience and Engineering, IISc Bangalore. After finishing his PhD in the area of optoelectronic applications of two-dimensional material, such as graphene and molybdenum sulfide, he joined as a national postdoctoral researcher at ECE Department, IISc. Currently, he works as postdoctoral researcher at Center for Quantum Devices, Niels Bohr Institute, University of Copenhagen. He primarily works on topological quantum computing with an emphasis on stable nanofabrication process for new class of materials. Welcome you, Dr. Sangeeth Kallatt, to our webinar. Over to you, sir, now.
Okay, thanks. Englishലാണോ മലയാളത്തിലാണോ?
However you are comfortable.
അതല്ല, ഇത് എല്ലാവരും മലയാളികളാണോ അതോ മലയാളം അറിയാത്ത ആൾക്കാരുണ്ടോ?
ചിലപ്പോൾ we have some people from outside. But
Okay,
audience,
okay.
yeah, okay. Mostly ഞങ്ങളുടെ students തന്നെയാ, and students and faculties ആണ്. But sometimes yesterday we had somebody from Nigeria. അപ്പോൾ പറയാൻ പറ്റില്ല participants അങ്ങനെ ഉണ്ടോ എന്നുള്ളത്.
Okay. ഞാനത് മെയിനായിട്ട് നമ്മളുടെ നാട്ടിലുള്ള ആൾക്കാർക്ക് വേണ്ടിയിട്ടാണ് ഞാൻ പ്രിപ്പയർ ചെയ്തത്. I didn't know that it's an international discussion.
Yeah, okay. Yeah.
Okay, fine. I'll speak in Malayalam.
Okay, yeah, sure.
I think that will be more convenient for all.
Yes, of course. Okay.
Well, I don't have any preference on those.
Okay. Yeah.
Let me try to figure out how to share my PPT. Okay, I haven't done it before.
Okay, yeah, sure.
Let me try this. So can you guys see it now?
Yes.
Okay. Okay, should be fine now.
Yes.
Okay.
Fine. Yeah.
Fine.
Okay.
അപ്പം ഞാനിപ്പോൾ ഇത് ഉദ്ദേശിച്ചിരുന്നത് എന്താണെന്ന് വെച്ച് കഴിഞ്ഞാൽ it's not like a course, it's not like a talk. I just want to give an introduction to what is this microfabrication and all this about. എന്താണ് ഈ microfabrication എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ മൈക്രോ ഇലക്ട്രോണിക്സ്, നാനോ ഇലക്ട്രോണിക്സ്, ചിപ്പ് ഫാബ്രിക്കേഷൻ. നമുക്ക് ഇതിലൊരു കരിയർ ബിൽഡ് ചെയ്യണമെന്ന് വെച്ച് കഴിഞ്ഞാൽ what should we do? How do I turn off this video?
Which one?
I don't want to see me. It's annoying.
Oh, but then it just appears as on a small screen over here.
Yeah, is that stop video?
Yeah, stop video. Sure.
Okay.
Yeah.
Okay, fine.
Okay.
Fine. That's better. ഞാൻ അതാണ് ഉദ്ദേശിക്കുന്നത്. അതായത് ഈ മൈക്രോ ഫാബ്രിക്കേഷൻ എന്ന് പറഞ്ഞാൽ എന്താണ്, നമ്മൾ അതിൽ ഒരു കരിയർ ബിൽഡ് ചെയ്യണമെന്ന് വെച്ച് കഴിഞ്ഞാൽ നമ്മൾ എങ്ങനെയായിരിക്കണം നമ്മുടെ സ്റ്റഡീസ് നമ്മൾ അലൈൻ ചെയ്യേണ്ടത്, പിന്നെ എന്തൊക്കെയാണ് അതിൽ ആവശ്യമായിട്ടുള്ള ബാക്ക്ഗ്രൗണ്ട്, അതിൽ എന്തൊക്കെയാണ് നമ്മുടെ പ്രോസ്പെക്ട്സ്, ഇതൊക്കെയാണ് ഞാൻ പറയാൻ ഉദ്ദേശിക്കുന്നത്. ആൻഡ് മൈ ഔട്ട്ലൈൻ ഈസ് ഐ വിൽ ഗിവ് എ ക്വിക്ക് ഇൻട്രൊഡക്ഷൻ ടു നാനോ ടെക്നോളജി. ഇറ്റ്സ് എ ബിഗ് ഫീൽഡ്. അതൊരു ഒറ്റ സ്ലൈഡിൽ എനിക്കത് മുഴുവൻ പറയാനൊന്നും പറ്റില്ല. പക്ഷേ ഞാനത് എന്താണ് നമ്മളതിൽ ഈ നാനോ ടെക്നോളജി അല്ലെങ്കിൽ നാനോ ഫാബ്രിക്കേഷൻ എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ നമ്മൾ എന്താണ് ഉദ്ദേശിക്കുന്നത്, പിന്നെ വാട്ട് ഈസ് സെമികണ്ടക്ടർ ഫിസിക്സ്, വാട്ട് ഈസ് സെമികണ്ടക്ടർ ഡിവൈസ് ഫിസിക്സ്, പിന്നെ എന്താണ് മൈക്രോ ഫാബ്രിക്കേഷൻ എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ, പിന്നെ നമ്മളതിൽ നമ്മുടെ കരിയർ പ്രോസ്പെക്ട്സ്. അപ്പോൾ ഇങ്ങനെയാണ് ഞാൻ അതിൽ ടോക്ക് അലൈൻ ചെയ്തേക്കുന്നത്. അതായത് നമ്മുടെ കരിയർ നമുക്ക് എന്തൊക്കെയാണ് നമുക്ക് അതിൽ പഠിക്കേണ്ടത്, എന്തൊക്കെയാണ് നമുക്ക് ജോലി കിട്ടുക, പിന്നെ നമുക്ക് നാട്ടിൽ ഇന്ത്യയിലുള്ള മെയിൻ ആയിട്ടുള്ള ഇൻസ്റ്റിറ്റ്യൂട്ട്സ് ഏതൊക്കെയാണ്, ഇതിനെക്കുറിച്ചൊരു ക്വിക്ക് ഇൻട്രൊഡക്ഷൻ. ഇതാണ് ഞാൻ മെയിനായിട്ട് ഉദ്ദേശിക്കുന്നത്. അപ്പോൾ 1 hour ആണ് ഞാൻ ഉദ്ദേശിക്കുന്നത്. ചിലപ്പോൾ അതിന് മുമ്പ് അത് കഴിഞ്ഞു എന്ന് വരാം. ഇഫ് യു ഹാവ് സം ക്വസ്റ്റ്യൻസ് വി ക്യാൻ ഡിസ്കസ് ദിസ് തിങ്. ഓക്കെ, ഈ നാനോ ടെക്നോളജി എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ എല്ലാവർക്കും അത് അറിയാമെന്ന് ഞാൻ വിചാരിക്കുന്നു. മെയിനായിട്ട് നമ്മൾ ഈ നാനോമീറ്റർ ലെവലിലുള്ള പാർട്ടിക്കിൾസിനെ വെച്ച് നമ്മൾ ഡീൽ ചെയ്യുന്ന ഒരു പരിപാടിയാണ് ഈ നാനോ ടെക്നോളജി എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ. അത് ഒരു വളരെ കോംപ്ലക്സ് ആയിട്ടുള്ള ഒരു ഫീൽഡാണ്. നമുക്ക് അത് ഒറ്റ വാക്കിൽ തന്നെ ഡിഫൈൻ ചെയ്യാനും പറ്റില്ല. പക്ഷെ ഇന്നത്തെ കാലത്ത് നമ്മൾ മെയിൻ ആയിട്ട് നാനോ ടെക്നോളജി എന്ന് പറയുമ്പോൾ ഉദ്ദേശിക്കുന്നത് ഒരു 1 to 100 നാനോമീറ്റർ റേഞ്ചിലുള്ള പാർട്ടിക്കിൾസിനെ നമ്മൾ മാനിപ്പുലേറ്റ് ചെയ്യുന്ന ഒരു ഏരിയയാണ് നാനോ ടെക്നോളജി എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ. I'm getting a pop-up. Is there anything?
Yeah, there is a like എല്ലാ വെബിനാറിലും വരുന്ന ഒരാളുണ്ട് പങ്കജ്. So I think he doesn't understand Malayalam.
Oh, okay.
There are some
then,
2-3 North Indians who have joined our, yeah. So
I see.
he was requesting you to speak in English.
Okay, I'll switch to English. Okay,
oh,
fine.
Okay, yeah. Thank you.
Okay, so it's a very complex field to define this nanotechnology in 1 or 2 sentences. So roughly, we can say that this is an area where we manipulate things at whose dimensions are between 1 to 100 nanometers. And for those who are not familiar with nanometer, a nanometer is 1e minus 9. So it's 1e minus 9 meters. So it's roughly 1,000th of your. If you take your hair and cut this by 1,000 times, one of these segments would be around a nanometer. So that's a rough approximate of a nanometer. And this nano comes in different sections. Like you have a nanosecond, you have a nanometer, you have so many nanos. But when you speak about nanotechnology, we typically deal about nanometers. One of the characteristic properties of these nanometers in this time is the variations of these particles. The particle size strongly changes the properties of the particle. For example, if you have a nanoparticle of 1 nanometer that has a particular characteristic properties, and if you have something of 100 nanometer that has a different property. I will come to that later. So what we see nowadays is the nature prefer to work in nano regime. So for example, most of the things we deal with, like our DNA, has roughly a few tens of nanometers in length. I mean, in width, I would say. The visible light is 400 to 700 nanometers, although you don't really consider that as a nanometer. Size of typical molecules are few nanometers or close to a nanometer. So in general, the whole nature works in nanometer as of now we understand. And when we change the particle size to a few nanometers, you will see quantum confinement effects. That's a little different field, but you don't see many of the things at bulk. But when you make this as a nanoparticle, you see a lot of quantum confinement effects where things are mind-blowing. You will see a lot of new physics coming out of it. You can make new types of devices out of it. So that's why many people are behind this nanotechnology. And you can really build things of your own. I mean, you can have materials where you want a custom-made properties if you are working in this nano regime. For example, I have given a couple of images at the right. If you look at the bottom, you will see this is a colloidal gold solution. So you have the left one is 20 nanometer gold colloidal solution. It has a pinkish color and reddish color. And when you increase the size to 60 nanometers, you see a gradual change in the color. So that is basically because of the band structure of this gold colloidal nanoparticle is changing with the radius of the gold nanoparticle. So as of now, when you see gold, bulk gold, it's yellowish and it doesn't have any color differences or any property differences when you whatever you do. But the moment you make it very thin nanoparticle, the whole system becomes very different from a bulk gold. So this is one characteristic example everybody talks about when you talk about a nanoparticle. And the image at the top, the peacock, the magnificent colors of this peacock, it doesn't have any pigment. This is just because of some different arrangement of fibers in a different way. It gives you, pigmentless color. So This is another example where the nanotechnology or this nano patterning works in the nature. So this peacock feather is an interesting structure because we use those things in a lot of optoelectronic devices. This idea of arranging things in a particular way and controlling the light transmission through that. This is a quick introduction to nanotech. What is this nano, or what do we mean by nanotechnology or nanofabrication in these days? So it has nothing to do with let's say nanosecond or something like that. It's only about the length dimension of nano. I'll quickly move to what is the next aspect of it. So probably I will take this peacock feather example from here. We arrange things in a nanometer size, and then you can see these kind of beautiful patterns. So we take the same thing, and we'll move to the next slide, which is semiconductor devices. So in semiconductor devices, we are making patterns of or devices of few tens of nanometers, and we expect these devices to show some particular properties. Okay, so this is one of these most interesting field nowadays, I would say, because of multiple reasons. Before we start, the semiconductors, semiconductor devices are basically made of silicon. For various reasons, because silicon is very easy to make, very stable material. So we are making devices with silicon nowadays. Although we have so many other semiconductors coming in, such as germanium, gallium arsenide, indium phosphide, indium arsenide. These are very expensive and very complex, but most widely used semiconductor is silicon nowadays. And once you have a silicon wafer, so the image which you see here, this is an 8-inch silicon wafer on which we have series of devices fabricated, and that's why you see a lot of colors on it. So each device, each small squares which you see, it's a chip. So this chip is fabricated on this silicon wafer by a series of processes, and we call these processes as micro or nano fabrication. People will say either micro or nano, depends on what context you talk about. You take the bare silicon wafer, and there are different processes which you do on this wafer one by one, and finally you get a chip on that wafer. So that's what typically we are doing. And when we talk about the type of different devices which you fab on semiconductors or silicon, we have a variety of segments, which is nano-electronic devices, MEMS, which is micro electromechanical systems or nano electromechanical systems, and devices for various other new techniques such as quantum computation and topological insulators and stuff like that. So many different variety of devices which you can fab using these techniques. So it's a very powerful technique, by the way. Specifically the devices, field effect transistors. Nowadays, that's the most widely used electronic device in all electronic nano electronic component in all the devices which we use, and accelerometers, pressure sensor, gyros, and etc. On this, the CMOS FETs, the field effect transistors, it should require a special mention, because this is something which is leading the semiconductor industry now. So, for example, if you take a normal processor, it is having billions of these transistors, and these transistors constitute the building block of all these gates and all these computers, laptops, everything. And in present day, the most advanced CMOS transistors are roughly 20 nanometers, or presently it's 20 nanometers, but in certain chips, it is coming all the way down to 7 nanometers, which is supposed to be the minimum gate length you can have with silicon semiconductors. So this is very brief introduction to the kind of semiconductors or semiconductor devices which we fab. and the process in which you convert a silicon wafer into a silicon chip is called a semiconductor fabrication, or from now on we will call a microfabrication or a nanofabrication. I have put some images. I took some images from Google, and I have. So this should give you a rough idea about what we are talking about. So this is a cross-sectional TEM of present day. This is NMOS. Basically, any FETs will be looking like this. So it's like source, drain, and gate, and you have the channel here. If you look at the scale bar, this is altogether 20 nanometers. So and you populate your chip with a billion or so many of these transistors to realize different kind of outputs. Now in the top left you have an accelerometer, so you see a lot of combs and they move in certain direction, and that measures your the rate at which your airbag in your car should pop up. We have a pressure sensor here. So this is an example for a nano electromechanical system. So you have a carbon nanotube which is connected. This is connecting to electrodes and suspended. These are made for specific some specific purposes. But this is just to give you an idea about the time, the scale at which we work on. If you look at this is like 100 nanometers. So this is 100 nanometers. You see so big, but you see this like a big structure, but it's very small, and it's only because you can zoom in and take an image at very high magnification, so you see that very big, but it's really small. For example, this carbon nanotube is the diameter of this carbon nanotube, which you see here. This is roughly like 1 or 2 nanometers in the diameter. So what I wanted to have you guys is that quick inception of the kind of image device structures which we look. So in all these things, it's silicon. So the background what you see here is silicon, and you have silicon and with some other gold, palladium, those kind of things. You deposit in a particular way and realize these kind of structures. I hope you have a rough image of what kind of devices we are talking about. It's not very big. It's really small. But you make billions of these on a chip, and the whole thing looks quite big. But if you take one of it, it should be really ridiculously small. And why should we talk about it? It's quite important nowadays for multiple reasons, because in this age we are talking about Internet of Things, and the whole objective of Internet of Things is connect you with outside the world surrounding with a series of sensors, and nowadays most of the sensors are working on CMOS. So you are going to be so much dependent on when you talk about these sensors, you can't make a good sensor without a CMOS. So it's going to be very important in the next generation that you have a good hang of microfabrication processes, and you can make all these sensors with reliably and according to whatever needs you are going to have. So this is the idea which all of us are talking about now, that make sensors reliably, which can be custom made for a particular thing, and all these sensors are essentially coming from microfabrication. And the last point of it is economics of these semiconductors. Now you must be seeing all these issues happening about this 5G, Huawei. Some people are not liking Chinese companies, and some people are all this drama is happening because when you make a chip, you can make few things which can be basically used for taking your data out. So many people think about the company or the country which makes this chip can basically sneak into your privacy. So people are really concerned about sharing these things with other countries. So that's a security and data laws, and this comes like a soft power as well. And another big aspect of that is the monetary, the economy, because if in India in 2020 we are expecting $50 billion of worth import on electronic, basically the chips. So 50 billion is a mind-blowing number, and at present we import 100%. So this is 1 year, and it's going to this is expected to increase by 25% in 5 years. So it's going to be a lot of money. So we are so much dependent on it, on other nearby countries for getting all these imports done. So this is very important that we should get things done in India. Okay, so this is not really meant for these beginners, but this is some high-level discussions going on now in India. Anyway, okay, so let's if you come back to the technology, where do we make it? I mean, by now you must be realizing that we are talking about very small patterns and very small devices. So it's very clear to everyone that we can't make all these things in a normal lab, because in normal lab we have so many dust particles and so many other variables. So you can't make all these things reliably in a normal lab. So we need a clean lab. So we call it as a clean room from now on. So all these chips are made in clean rooms. So this is a special room where you have controlled ultra clean environment. It is free from all sorts of dust, electronic noise, normal noise, vibrations, everything. It has a controlled temperature, humidity, and special lightings, special air filtration, and such a room is called clean room. I just wanted to publicize myself. So this is me in a clean room. I mean, I'm counting in, and this is inside the clean room. This image is inside the clean room. By the way, are you guys able to see my cursor movement? Hello.
Hello.
Can you see my cursor movement?
Yes, we can see.
Okay. Good.
Okay.
So this is inside our clean room, and yeah, so you can see, for some reasons I can't take so many images, so I have to just take one or two images of it. So the clean room, again, the clean room is a very costly enterprise, because we need to have a continuous water supply. We have to maintain continuous running, because we have to maintain the quality of the air. Tools cannot be turned off, so it's a very expensive thing. So we have kind of different clean rooms for different purposes. For example, some clean rooms need a very clean environment, and it's very expensive. But for some of them, you don't need that clean environment, and you can make it different, slightly less clean. So we generally call different classes for each clean room. Like class 1000 is a okay average-ish clean room. Class 100 is even cleaner. Class 10 is clean, even cleaner. Class 1 is cleanest. So I haven't worked in class 1. I haven't even seen them, but class 100 is something like a very nice clean room for nowadays. So the take-home message from this slide is, it's not a normal lab or normal factory where you make all these things. It's a special environment where we have different protocols for like you can see, I have a gown, and at some point I will cover my face as well when I go to the clean room. So we are making all these chips in this kind of environments. It's quite fancy. I just wanted to give you a quick glimpse of the main processes which we do for converting a silicon wafer to a silicon chip. Main processes are one is lithography. It's not easy for me to explain all these things in a single slide. It needs a lot of discussions on it. So lithography, I can give you a single line explanations or descriptions to all of them. So by lithography, we mean making patterns on silicon wafer by certain methods. So this is the main bottleneck in most of the cases. You have to, if you want to make small structures, you have to make small patterns just by doing this, high class lithography. Next main process is etching. It's a removal of material from specific portions with specific, either by a wet chemistry or by a plasma, and using certain very high-end tools. Another process is deposition. Many of the times you need to have metal contacts to your silicon chip. So for that you have to put gold or aluminum or copper. For that we use this technique called metal deposition or dielectric deposition. And finally, once your chip is fabbed, you have to bond it so that you can take it and connect this to your mobile phone or a laptop or whatever. So this is bonding. So these are roughly the most critical steps or most important steps in microfabrication, or same thing in nanofabrication. We do these processes one by one. Generally, you have a sequence for fabricating an FET. You have a sequence of like do the lithography, etch, go back to lithography, etch, and in between you deposit some metal. So the process flow will be made by someone, and you have to execute this by many times to realize this chip. So that's how generally it works. And bonding comes at the last stage, where you can take this chip from silicon to your mobile phone or like whatever. Okay, I know this is not very explanatory. It's not easy for me to tell all these things much, as I said. So, but I think this will give you an idea about what it is. And I have made some points for the students to get a hang of what are the things needed in these days to make your career in this field. Firstly, what are the options available currently? So the first one is you can do a research in microfabrication or in this nanoelectronics or whatever. So and you can do this research even in an academic environment like I do now, or you can work in industry. Another option, especially in India, is a process engineer. You can work like a process engineer, where you will be doing certain processes in certain clean rooms. And otherwise, you can have a job which is operating a clean room. That by itself needs a different skill sets. In India, it's mainly academic because we don't have any industrial clean rooms in India. Of course, you have so many different clean rooms very near to India. Like if you go to Malaysia or Singapore or Taiwan, you have so many clean rooms. But in India, we don't have any industry clean rooms. And another job which is very popular in India is you have very high-tech tools which is used for this clean room fabrication or for microfabrication. So you need people who can fix these things, fix these tools, like engineers or scientists. So that itself is a big deal in India. I mean, there are so many people, so many big companies are having those who are having this kind of offices in India. So that is another set of jobs rising nowadays. And slowly we are having a few startups, especially in Bangalore. So of course they are slowly taking momentum, but they are recruiting people nowadays. So this is a rough picture of the job horizon you have in microfabrication in India. And the nature of the jobs, how does it look like? So in most of the cases, it looks like this background image. You'll be working like this. And for researchers, the job description would be that you have to work on new designs for new devices. You have to make new processes. You have to make new process flows, or it's basically like an academic thinking. So and in India, you are having mainly it in academics, but I see in outside, like in Europe, we have researchers from industry as well. And process engineer, as I said in the last slide, you have to optimize certain processes. You have to make sure that this is not drifting with time, and you have to make sure that one process is compatible with the next process. So that's called process integration. So these are the typical processes for a process engineer. So in academic clean rooms in India, it's mainly the job is mainly for this process engineer, where you have to basically make sure that processes are in place. By process, I mean the lithography, etch, deposition, and different tools doing these processes. And if I consider the pupil, like the skills needed for these kids for getting a job, mainly we look for, mainly people look for engineering and science. In science, it doesn't really discriminate between mathematics, physics, chemistry. So if you have a master's, typically people expect a master's in your science to get a basic job in entry-level job in process, like a process engineer. Or for engineering students, minimum you need a BTech, bachelor's, or it would be very nice if you have a master's. Bachelor jobs, if you have a bachelor's degree, you can have a basic entry level job, but I would probably recommend you to have a master's before you enter into this field, because that will improve your levels. Your career will be much smoother if you have a master's. I would probably look for that. So especially when you have an engineering, I suppose this is an engineering college, so I thought I will speak about engineering a little. So in general, what I have seen is mech-eng people, they are on high demand for MEMS and NEMS, like accelerometers, pressure sensors, and making new designs for that. I have a friend of mine who just finished his he fabricated a gyroscope, and next month he got a job. So it's a little challenging, but if you make it, you are going to have a nice boost just because of that. And in the country, these government labs are hunting for kids with new ideas on this MEMS structures, because as you can see, all these Chandrayaan, Mangalyaan, and all those things are heavily dependent on these pressure sensors and accelerometers, so that the lunar probe can land exactly on with the correct velocity on the lunar surface or Martian surface or whatever. So this is a thriving field at this point of time. And engineering people are well required for designing new tools with particular for this microfabrication, you need so many high-tech tools, and we are buying all these tools from outside, but ideally we would expect this to make that in India, and for that you need people from all sorts of backgrounds. So it's a highly complex integrated field. Especially, and another point is a good idea about these vacuum systems. I don't know whether these engineering people are really studying these vacuum systems, but that is something which is highly required for these jobs. But I think there are some special courses where you can learn about these vacuum technologies. And additional skills or the academic qualifications for researchers, it's definitely needed a PhD or a master's. And for process engineer, at least a bachelor's to start with, or I would prefer a master's, as I said. And some extra qualifications. It would be good to have an idea about this vacuum technologies, tool design, and another important factor is automation. How can you connect a couple of tools together and work make it automatic measurements and stuff like that. And another important factor is data processing, because you are generating a huge amount of volume of data, so you need to make you have to make some sense out of it. It would be good to have an idea about these softwares, mainly Python, at least Python and MATLAB and LabVIEW and like NA tools. So these tools will give you a nice it will be a nice platform to do all this data processing and system automation and stuff like that. So yeah, so you can, if somebody is looking for a career in this direction, I would say you should have your BTech or at least a BTech or a master's with this kind of additional software training, that would be very helpful. And some associated points, it's not very exhaustive, but I'm listing out some of the clean rooms in India. I would say the first one is the one in Bangalore. So this is Sense in IISc. So this portion, the red portion, is the clean room. So it has one of the biggest clean rooms in India. IITB and IIT Chennai has similar clean rooms. And there is a big clean room in Chandigarh, which is Semiconductor SCL Chandigarh. They make most of the chips for DRDO and ISRO. Some important institutes which are having courses in microfabrication. The first one I would count IISc. Sense has a couple of courses, and ECE also runs a very important microelectronic course. That would be, those are considered very nice courses. IITs, especially IITB, also runs a VLSI microelectronic course, and all the new IITs are also coming up with new courses. So these are the main institutes where you can do a master's or a PhD in this microfabrication. The career opportunities in India, it's mainly academic, as I said, because most of the clean rooms are in academics in the universities. Although you have in Bangalore, I have seen many of the international chip manufacturers are having design offices, so many people work there. And if you want to work in an industry clean room, the most closest option is the Southeast Asian countries like Taiwan or Malaysia. And there are so many clean rooms in Malaysia and Taiwan. And then it comes to US and Europe. So Europe, Germany has so many clean rooms. So this will be a ballpark idea, where you will land if you have a job, if you want to have a job in this field. I think I'm done with that. Thank you for your attention. And all these images are taken from Google Images, so I didn't put all the links, but yeah, it's all taken from them. Yeah, if you have some questions, I would be happy to answer. I have 20 minutes.
Yes, Dr. Sangeeth, thank you for this informative session. Okay, I have some instruction to the audience. We are posting the feedback form in the chat box of the YouTube link as well as the Zoom chat. So you can fill in the feedback and send it back to us. This would be considered as a record of proof for your attendance. You need to attend at least 5 webinars out of the 7 to get the e-certificates, which shall be issued in 2 days after the whole of the webinar series. You can post your questions in the question answers or in the chat box or in the YouTube chat. Yes, please. Yes, Dr. Sangeeth, I think we have a question in the question answers. Can you see that?
Okay, let me check. Yeah, considering the Moore's law, yeah, so 7 nanometers, yes, 7 nanometers is something which we are also thinking the down limit of silicon. Yeah, so we don't know what is going to happen after 7. Heard even 5 nanometer chips are coming. Yeah, there are discussions about it, but we have to see because we are seeing a lot of other issues associated when you have 5 nanometer chips. So it's too hard to say at this point whether we can really make a reliable 5 nanometer chip. I think that would be that answer for Gregory Paul George. Mechanical engineering student have any job opportunities in Kerala state? For Kerala, so I think ISER Trivandrum is planning to make a fab. Okay, so there are 2 things in Kerala currently coming up. One is in ISER Trivandrum, and there is another. What is that called? I forgot its name. So it's VSSC is starting a new clean room, but they have not started it yet. But they would be soon starting VSSC and ISRO together. So it's going to be very close to ISER. So yeah, so I think once they pick up, they will be giving some jobs to, yeah, so that would be an option if you want to stick in Kerala. But you should just go out of Kerala and explore things. Yeah. So I have two questions, and I think I'm done with this. Is there anything else?
Yes, Dr. Sangeeth. Yeah, we're just checking up if we have some questions on the YouTube link. Okay.
Okay.
Yeah. Dr. Sangeeth, I have a question.
Mm-hmm.
Yeah. Which market do you think demands the nanotechnology mostly? Like in the current scenario, is there some market that demands the most out of nanotechnology? Is it the medicines or what is it that is
Oh,
upcoming?
it's too tough to say which
Okay.
one. I mean, of course, medicine is many people are. I mean, everybody's looking for a medicine field, but it's not only medicine. I mean,
Okay.
yeah, it's
Or
too
which
crude to
field
say.
is the research being like very aggressively being done?
In the current corona crisis,
Yeah,
or in general.
in general.
In general, I don't know about other fields, but
Uh-huh.
nanofabrication is aggressively done, very, very
Okay.
aggressively. I mean,
Okay.
if you see all these trade wars and all those
Uh-huh.
things, they are all heavily because of the fabrication facilities.
Okay.
Yeah, it's
Yeah.
quite aggressive.
Okay. So, as far as a mechanical engineering student is concerned, after his BTech, then he must be doing some specialization in his MTech too, in his post graduation related to nanotechnology, or is it just in the PhD that he can opt the nanotechnology?
No, no, no. If in my personal opinion, you don't have to really go for a nanotechnology course. You can do a
Okay.
bachelor's. You can do a
Okay.
bachelor's, and you can have a master's in mechanical or associated fields,
Mm-hmm.
and then you are done.
Okay.
Nanotechnology. I mean, I have seen these courses where they say it's nanotechnology course, but I don't
Okay.
really think it's really needed.
Okay.
If you are a mechanical eng, if you are a mech eng, and if you are good at it, you have a job.
Yeah. Okay. Yeah. What, you were a mechanical engineer, right? Your
No, no, no.
graduation was in?
I'm from physics.
Okay, you're in physics. Okay, fine. Yeah. And in the corona crisis, is something being done in the medicine field?
I
Efforts
can't really.
from the nanotechnology?
Uh,
Like, is there something that we can hope for that comes from the nanotechnology that can help this crisis?
that's too tough to say. Actually, I don't work in
Okay.
medicines. I can really comment
Okay.
on that. Yeah.
Okay, fine. Yeah. Okay.
Oh, I didn't realize that I turned off my video. Okay, fine.
Okay, I thought you didn't want to on the
No,
video.
no, no, no. I turned it off earlier, but yeah. No.
Okay, yeah, fine. Okay, yes, I think we are done with the questions.
Mhm.
Okay. Yes, Shafi, do we have on the YouTube? Yes, Dr. Sankeet, I think we have one more question on the question
Mhm.
answers.
Okay.
Yeah. How can batteries, there's a question from Grigory. How can batteries be favored from nanotechnology?
This lithium-ion batteries. That's a quite aggressive research area by itself. But it's very complex to say in one or two sentences. But what I can tell is there is a huge research activities happening on how to improve the efficiency of lithium-ion cells, which can be essentially used for these electric vehicles. And it's quite aggressive in India also. And there are so many new companies coming in South India to do this research on lithium-ion batteries. I can't really tell much intricate details because I personally don't work in that field. But what I can say is there's a huge funding and private industries are jumping in this field.
Okay. Yes, I think there are no more questions now.
Mm-hmm.
Okay. Yeah. So how do you feel? What's the feedback about our webinar? How did you feel? Was it comfortable?
Oh yeah. I mean, it's fine.
Yeah.
I mean, I wanted to see a lot of people, but apparently I see only you, so it's fine.
Okay. Okay.
Yeah, but I assume that there are mute spectators when
Yes,
word
yes,
is
yes.
watching.
Yeah.
Okay.
There are
Yeah,
about 100 spectators. Yeah.
yeah,
Some of them has, yeah.
it's not very nice to speak to a
Yeah.
monitor.
Yeah.
It would be nice if we can see people on face,
And
but
if it was an
and you then you
interactive
will
session.
it
Yeah.
would be more interactive. Now it's like
Oh,
I'm speaking to myself. Like
okay.
yeah. Anyways,
We'll take up
okay.
this comment for
So
our next webinar.
oh,
Okay.
but no.
Yeah.
It's not. I mean, it's just like what I feel. I mean, I don't have any
Okay. Yeah.
complaint. I
Okay.
think the information is important than this. Anyway.
Yeah. Okay.
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 Thanks.
Yeah.
Thanks.
Thank you. Thanks a lot, sir.
Nice meeting you guys. Bye bye.
Okay. Thank you.